Each year, the local country club sponsors a tennis tournament. The tournament starts with 128 participants. 128 participants represents my p-value. During each round, half of the players are eliminated. Rate will be negative 50% or negative 0.5. After how many rounds tells me t is not time, so I'm going to change the t to an x value, number of rounds. After how many rounds tells me that I need to solve for an x value. What would that mean a needs to equal? A is the amount that's left. How many people are left when a winner is decided? 1. I'm going to write down a equals 1. Hopefully it's pretty obvious that we need to use the equation a equals t times the quantity of 1 plus r to the t power. If I'm solving for time, I have to fill something in for p, r, and a. The tournament starts with 128 participants. During each round, half of the players are eliminated. After how many rounds will the winner be decided? 1 minus 0.5 is 0.5, or 1/2 is a fraction. You can't multiply 128 by 1/2 because the 1/2 is being raised to the x power. Order of operations won't let you multiply them. I'm going to get the x a little bit more alone by dividing both sides by 128. The next step will give me 1 over 128 equals 1/2 to the x power. Now we're going to analyze this a little bit. We've been going over numbers raised to powers for quite some time. You should know that 2 to the 7th is 128. So what I'm going to do is something I call a swap-opportunity. I'm going to swap out 128 for 2 to the 7th power. 1/2 to the x power means I really have 1 to the x power over 2 to the x power, because when you have a fraction raised to a power, you really raise the numerator and denominator each to that power. Make sure you have parentheses before you commit to doing something like this. 1 to the x power is going to be 1. 1 raised to any power is still 1. 1 over 2 to the 7th power equals 1 over 2 to the x. When you do something like this, you're using something called the one-to-one property. We're going to talk about the one-to-one property more in the next few sections, but here's just a little bit of a sneak peek of what it's like. If you stare at this long enough, it should dawn on you that 7 is equal to the x value. That means after 7 rounds, a winner is decided. Do you remember another time that we used the phrase one-to-one? We used the phrase one-to-one when we talked about graphs that pass both the vertical line test and the horizontal line test. We had 1 x value for every 1 y value. It also told us that the equation we were working with was a function and that its inverse would be a function as well. Another way to do this problem is in a sort of cheap way. If you have 128 players going into the first round and half of them are eliminated, and coming out of the first round you only have 64 players. 64 players going into round 2 and half eliminated, so we only have 32 players coming out of round 2. 32 players coming out of round 2, 32 players going into round 3. Half of them are eliminated, which means we only have 16 players coming out of round 3. 16 go into round 4, 8 come out. 8 go into round 5, 4 players come out of that. 4 players go into round 6 and only 2 come out. And then 2 players go into round 7, only 1 comes out victorious. Each year, the local country club sponsors a tennis tournament. The tournament starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? We could still look at this problem the same way we did before and just really say, okay, fine, there's 4 players left. However, we could also do a problem like this algebraically. If we were to do a problem like this algebraically, we would still use a equals p times the quantity 1 plus r raised to the x power. My p-value is still going to be 128. My rate is still going down by 50%, which gives me a 1/2 inside my parentheses. After 5 rounds would mean I'm filling in a 5 for the x. 128 times 1/2 to the 5th power. If I'm raising 1/2 to the 5th power, that's 1 to the 5th over 2 to the 5th. 1 to any power is still 1, and 2 to the 5th is 32. You could divide 128 by 32 and get 4. However, another way we can do it, sometimes I prefer to think smarter, not harder, and I like to break my numbers down and make them smaller rather than make them bigger. Since I know 128 is 2 to the 7th power, I could still think of this as 2 to the 7th power times 1 over 2 to the 5th power. Properties of exponents has taught me I could subtract my exponent. 7 minus 5 leaves me with 2 to the 2nd power. That means 4 players. Suppose an account starts with $100 and has an annual interest rate. So over the course of 1 year, get 4%. Find a bank account balance after 12 years if no other deposits are made. Well, here it doesn't say anything about compounding continuously or even quarterly, monthly, yearly, or anything like that. So that means we're going to use the equation A equals P times the quantity of 1 plus R, or R over N, raised to the T, or NT. I say or because I could just look at N as being 1 and fill it in anyway. P is 100, R is 0.04, T value is 12 for 12 years, and number of times the interest is compounded in a year is just 1. That means I must be solving for A. A of 12 equals 100 times the quantity of 1 plus 0.04 raised to the 12th. 1 plus 0.04 is obviously just 1.04. I need a calculator to figure out 1.04 to the 12th power. Calculator gives me 1.601032218, yada yada yada. Make sure you're not just rounding to a few decimal places. Leave all those decimals on your calculator window. From there, just press times 100 and you'll get $160.10 after rounding to the hundredths place. In 1985, there were 285 cell phone subscribers in the small town of Centerville. Pretend the number of subscribers increased by 75% per year every year after 1985. How many cell phone subscribers were in Centerville in 1994? Round to the nearest whole number. I'm going to use A equals P times the quantity of 1 plus R to the T. It's not a banking problem, so I really don't need the N value that I've seen in the other equation. My initial value P is 285. My rate is negative 0.75. T is the number of years. Since this problem starts with its initial value of 285 cell phone subscribers in 1985, I'm going to let 1985 equal year 0. How many years have passed since 1985? All we need to do is subtract, and we'll get that T is 9. The amount of cell phone subscribers after 9 years equals 285 times the quantity of 1.75 raised to the 9th power. I'll use the calculator to raise 1.75 to the 9th power. This gives me 153.936794281, yada yada yada. Multiply that by 285. The amount of cell phone subscribers in Centerville in 1994 is approximately 43,872. Bacteria can multiply at an alarming rate. Certain bacteria can easily split into 2 new cells, thus doubling. If we start with only 1 bacteria, which can double every hour, how many bacteria cells will we have by the end of 1 day? Round to the nearest whole number. A equals P times the quantity of 1 plus R to the T. The problem mentions that the bacteria is doubling. When something doubles, that means that it's going to increase by 100% of itself. Increasing means we'll have a positive rate. 100% as a decimal is really 100 divided by 100, which means I have a plus 1 as my rate when I use my rate as a decimal. P is the principal amount. I start off with 1 bacteria. Here it says at the end of 1 day, but we double every hour. So if my time's in hours, I'm going to use T equals 24. If I fill in all of these values, I'll get A equals 1 times the quantity of 1 plus 1 to the 24th. 1 plus 1 is 2, giving us that feeling of doubling. 1 times 2 to the 24th. If I type that into a calculator, I'll get the amount of bacteria after 1 day equals 16,777,216 bacteria. An adult takes 400 milligrams of ibuprofen. Each hour, the amount of ibuprofen in the person's system decreases by about 29%. How much ibuprofen is left? We're going to use the equation A equals P times the quantity 1 plus R raised to the T power. We're looking for the amount of ibuprofen left. A is unknown. P is how much ibuprofen we start with, 400 milligrams. The amount of ibuprofen left in a person's system is decreasing by 29%. That gives me an R value of negative 0.29. Time is measured in hours, since not only are we describing how it decreases hourly, but we're also asking how much is left after a fixed number of hours. T will equal 6. The amount after 6 hours equals 400 times the quantity of 1 minus 0.29 raised to the 6th power. 1 minus 0.29 gives us 0.71. 0.71 to the 6, 0.128100, yada yada yada. Leaving that number on the calculator window, I multiply by 400 and I'll get after 6 hours approximately 51.24 milligrams of the original 400 milligrams remains in a person's system. During normal breathing, about 12% of the air in the lungs is replaced after one breath. That means 88% of the air in a person's lungs remains after a single breath. Write an exponential decay model for the amount of the original air left in the lungs if the initial amount of air in the lungs is 500 milliliters. How much of the original air is present after 240 breaths? A equals P times the quantity of 1 plus R to the T. We're looking for the amount that's left, so that right now is unknown. P is how much we start with, which is 500 milliliters. The amount of original air decreases by 12% every time we take a breath. That means my rate is negative 0.12 as a decimal. T, which isn't really time, represents the number of breaths. We want to know how much of the original air is left after 240 breaths. 1 minus 0.12 will give us 0.88, since we mentioned that 88% of the air remains in the lungs after one breath. 0.88 raised to the 240 power in a calculator will give us 0.000000, whole bunch of zeros, 47. If I multiply that by 500, we'll have 0.0000000000237 milliliters of that original air remaining. If we wanted to write this with scientific notation, that would be 2.37 times 10 to the negative 11th power milliliters. 10 to the negative 11th power is really multiplying by 1 over 10 to the positive 11, which is really dividing by 10 to the 11th power. All of these represent the same answer. The second line really shows us scientific notation, which you'll probably use in chemistry. Sometimes when you do problems like this in a calculator, your calculator will actually give you an answer using scientific notation as well. However, they're going to use either a capital or lowercase e to show that you'll have an exponent of negative 11. So it might look something like this: 2.37 e negative 11. So if you see that, make sure you're not putting 2.37 as your answer. That's not correct. It's really point, whole lot of zeros, 10 zeros, 237, because your decimal had to move over 11 times to the left for your scientific notation. An inherited piece of land. Originally purchased for $30,000 in 1960, its value increased by 5% each year. What's the approximate value of this land in 2011? Swapping out capital A for a V to represent value. My principal is 30,000. T is the number of years between 1960 and 2011, which is 51, and rate is positive 0.05. The value is 30,000 times 1.05 to the 51st power. After evaluating 1.05 to the 51st power in the calculator, 12.0407697775 yada yada yada, reading that on the screen, multiply 30,000, the value of the land is $361,223.09. Say you deposit $1,600 into a bank account, annual interest compounded yearly. Find the balance after 3 years if the account pays 4%, annual interest A of T equals P times the quantity 1 plus R over N to the NT. Don't know the amount. P is $1,600. T is the time of 3 years. The rate is positive 0.04. N is the number of times the interest is compounded in 1 year. That would just be 1 since it's only compounded yearly. A of 3 equals 1,600 times 1.04 to the third power, 1.04 to the third power in the calculator, 1.124864 yada 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 times 1,600. The amount of money in the account after 3 years is $1,799.78 when 4% interest is compounded annually. What if we deposit $1,600 into a bank account and we want to find the balance after 3 years if the account pays 2.5% annual interest, so less interest, but now it's compounded monthly? How much money will we have if we start with $1,600 after 3 years where the interest rate is 0.025 and our N is 12 because we're compounding this interest monthly? So not only are we building on the amount of money every month, but we're also taking that 2.5% annual interest rate and we're going to divide it by 12 in the problem because you only get a small amount of this interest each month. Using the same equation and filling in right away, we'll get A equals 1,600 times the quantity of 0.025 divided by 12 plus 1. We'll get 1.0020833 yada 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 to the 36th power. I'm just using a separate calculator on the computer. Is 1.07780006124 yada 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 times 1,600 equals the amount of money in the account after 3 years is $1,724.48. So that's the amount of money we'll have if we have 2.5% annual interest if it were to be compounded monthly. For this problem, we're looking at a deposit of $1,600. The account has a 1.75 annual interest rate, and that is compounded quarterly. We want to know what will the balance be after 3 years. P equals 1,600. R is 0.0175 annual interest. Quarterly means 4 times per year, so N is equal to 4. T is the number of years, and in this problem, that would be 3 years. Amount after 3 years equals 1,600 times the quantity of 1 plus 0.0175 divided by 4 raised to the 4 times 3 power. So the exponent will be 12. Now I need my handy dandy calculator if I want to figure out the base for this particular exponential model. 0.0175 divided by 4 plus 1 is 1.004375. Then I need to raise that number to the 12th power. 1.004375 to the 12th power gives us 1.05378188867 yada yada yada. Take that number and multiply it by 1,600. Our account balance would be $1,686.05 after 3 years, when the 1.75 interest is compounded quarterly for 3 years.